Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to optics in the chapters of lenses and formation of images. This exercise was a previous one in the Brevet exams in 2010, third session, first exercise. The title of this exercise is Image Given by a Converging Lens. The aim of this exercise is to choose out of two positions of an object, the one that allows us to obtain through a converging lens an erect image larger than the object in size. For this purpose, we consider a converging lens of focal length f is equal to 2 cm and a luminous object AB of height 2 cm. Here the height represents the size of the object. Now part 1, first experiment. We place the object AP at 1 cm in front of L, perpendicular at A to the optical axis of L. Part 1. Construct in a real scale the image A prime B prime of AB given by L. Deduce the nature of A prime B prime. Okay, they are telling me construct, which means that I need to trace and justify at the same time. Notice that yet I didn't draw, or we don't have the optical system, and we didn't draw the optical system or any figure. So by construct here, we need first to construct the optical system. Then after we construct the optical system and we place the object AB and we place the foci of the lens L, the object focus and the image focus, then we will construct the image A prime B prime of AB. So as a first step, let's construct the optical system. Let's consider the direction of propagation to be from left to right, and in this case we take the optical axis in the same direction of that of propagation of light, from left to right. This is the optical axis. Now let's place the lens, the converging lens L, perpendicular to the optical axis at the center. Using the correct symbol. Now the intersection between the optical axis and the lens L is the optical center O. Now here they are telling me in a real scale. In a real scale means that along the x-axis we have 1 cm, and along the y-axis we also have 1 cm. Moreover, the focal length is given by f is equal to 2 cm. Okay, I need to place the object focus and the image focus. The object focus will be on the left and the image focus will be on the right, because the direction of propagation is from left to right, and the lens that I'm using is a converging lens. Because we are putting data on the graph, we need to divide by the scale. Here we are putting the foci along the x-axis, so we divide by the scale along which we are putting the data, which is the scale along the x-axis. So dividing by 1 cm will give me 2 divisions. Then the object focus will be located here, 1, 2, and the image focus will be located here. Now the object AB is at a distance 1 cm in front of L, perpendicular at A to the optical axis. Therefore A will be found on the optical axis. The distance is given by 1 cm. Since we are putting data along the x-axis, then we divide by the scale along the x-axis. So 1, it will give me 1 division. So 1 division in front of the lens. This will be the point A. Moreover, the size of the object is given by 2 cm. Now we divide by the scale along which we are putting data, which is the scale along the y-axis. In this case it's the same, 1 cm. It will give me 2 divisions. Then the point B will be located above A, 2 divisions upward. This is the point B, and we place a hat on the point B. Now let's trace the object. Now what we have done so far is constructing the optical system and placing the object AB. Now we need to construct the image A prime B prime. Okay, and I repeat, the word construct means that we need to trace and justify at the same time. So in order to to trace the image A prime B prime, we need to consider two rays issued from B. The first one that we will consider is parallel to the optical axis. We know that this ray will emerge passing through the image focus. And we don't forget arrows on light rays. The next ray that we will consider is passing through the optical center. We know that it will emerge without deviation. Okay, now we have done the tracing of the ray. Let's justify. So the path of the first ray is given by an incident ray issued from B parallel to the optical axis, emerges passing through the image focus, now the justification of the second ray is given by an incident ray issued from B passing through the optical center, in this case it emerges without deviation. So this is the tracing and the justification of the two rays. Now let's trace and justify the image. Notice that these two emergent rays, they don't intersect in front of the lens, behind the lens. In order to obtain the image we require for these rays to intersect, therefore we need to prolongate them backward. This is the prolongation of the first ray. Always the prolongation must be dotted, and this is the prolongation of the second ray. So what does this point represent? Because these prolongations are coming from these emergent rays that are coming from these incident rays that are coming from B, then this point will represent B prime, the image of B. Now moreover, a hat is found on B directed away from the optical axis, therefore also a hat will be found on B prime directed away from the optical axis. So let's place the hat. Now the point A here represents the foot perpendicular of B on the optical axis, therefore A prime will also represent the foot perpendicular of B prime on the optical axis. Let's trace the image. Okay, this is A prime, B prime. And now let's justify this tracing. Then the image B prime of B is the intersection of the emergent rays, of the prolongations Notice that the image here, A prime, B prime, consists of 2 points, B prime and A prime. So we have justified B prime, now we need to justify A prime. Now as we said that A prime and A prime is the foot perpendicular of B prime on the optical axis. Okay, now notice that in the same part 1, they are telling me deduce the nature of A prime B prime. Let me make some space. So we are still in part 1 of this experiment. They are telling me deduce the nature of A prime B prime. So notice that here both A prime, B prime and AB are on the same side of the lens, and whenever the object and the image are on the same side of the lens, this means that the image is virtual, since the object AB and the image A prime, B prime are on the same side, then the image A prime, B prime is virtual. Okay, so this is it for part 1. Now let's move to part 2. In part 2, they are telling me is the image A prime, B prime erect or inverted with respect to AB. So notice that the object AB is pointing upward and the image A prime, B prime as well is pointing upward. Therefore, both of them are in the same direction, which means that the image is erect with respect to the object AB. The image A prime, B prime is erect with respect to the object AB. Now in part 3 they are telling me find the length of A prime B prime. So the length, in other words, means the size of the image A prime B prime. Therefore let's calculate its size. Size of the image A prime B prime Now notice that A prime B prime consists of 4 divisions. And we multiply by the scale along which you have counted the number of divisions, which is 1 centimeter, and this will give me 4. Always all quantities in physics must have a unit. Finally, it's a good habit to write our final answer in a box to make the task easier for the corrector to notice our correct answer. Okay? Let me write the length here. A prime B prime is equal to 4 centimeter, and the nature is virtual. So this is it for the second experiment. For the first experiment, sorry. Now part 2, second experiment. Now the object is placed at 3 centimeter in front of L and perpendicular at A to its optical axis. Number 1. Construct in a needle scale the image A prime B prime A double prime B double prime of AB and deduce the nature of A double prime B double prime. Okay, so we need to construct on a new optical system. First, let's place the optical axis having the same direction of propagation of light, which is considered to be from left to right. Now let's place the lens L perpendicular to the optical axis at the center, in which their intersection is the optical center O. Now the focal length of the lens didn't change, therefore here is the object focus, 2 divisions away from the lens, in front of the lens, and f prime 2 divisions behind the lens. But now the object is at 3 centimeter. Okay, 3 centimeter dividing, since we are putting data on the graph, we need to divide by the scale, and we need to put A along the x-axis, therefore we divide by the scale along the x-axis, which is 1 centimeter. Let me place here the scale. And this will give me 3 divisions. Therefore now the point A is located here. Now the size of the object didn't change, which consists here of 2 divisions. Therefore the point B will be located above A, 2 divisions. Let's trace the object. Okay, now after we have constructed the optical system, now we need to trace the image A double prime B double prime of AB with its new position. Let me make some space above. Okay. And I repeat that the word construct means that we need to trace and justify. First, let's do the tracing, then we'll justify. Okay, in order to trace the image, we need first to consider 2 rays issued from B. The first one, parallel to the optical axis, we know that it will emerge passing through the image focus. Okay, and the next ray that we need to consider is passing through the optical center. And we don't forget arrows on light rays that indicate the direction of propagation of light. Now let's justify the path of these rays. An incident ray issued from B parallel to the optical axis emerges passing through the image focus. This is the justification of the first ray. Now let's justify the second ray. An incident ray issued from B passing through the optical center emerges without deviation and now we need to trace the image and justify it. So notice that these 2 rays, emergent rays, intersect behind the lens, and always the intersection of the emergent rays is the image of the object. Notice that these emergent rays are coming from these incident rays that are coming from B, therefore this point will be the image B double prime of B. Okay, we use the same notation here. Moreover, a hat is found on B directed away from the optical axis, therefore we need to place a hat on B prime directed away from the optical axis like this. Let's place the hat, and A represent the foot perpendicular of B on the optical axis, therefore A double prime will also represent the foot perpendicular of B double prime on the optical axis. This is A double prime. Now let's trace the image. So this is the tracing of the image. Now let's justify it. Then the image b double prime of b is the intersection of the emergent rays, and the image consists of 2 points, a double prime, b double prime. Therefore we need to justify the construction of b double prime, the tracing of b double prime, as well the tracing of a double prime. And a double prime is the foot perpendicular of b double prime on the optical axis. Okay. In the same part 1, they are telling me deduce the nature of a double prime, b double prime. Okay, so in part 2 we said since the object AB and the image A prime, B prime are on the same side, then the image is virtual. And the same goes here, but here the image is on opposite side. Since the image A double prime and the object AB are on opposite sides of the lens, AB is in front and A double prime, B double prime is behind. Therefore, in this case, the image is real. Let me make some space. Okay, so we are still in part 1 of the second experiment. We will say that since the object AB and the image A double prime, B double prime are on opposite sides, then the image A double prime, B double prime is real. Now in number 2, they are telling me is the image A double prime, B double prime erect or inverted with respect to AB. Notice that AB is pointing upward, whereas A double prime, B double prime is pointing downward, which means that A double prime, B double prime is an opposite direction with respect to AB, which means it is inverted. Okay, the image A prime, the image A double prime, B double prime is inverted with respect to the object AB. Now in part 3 they are telling me find the length of A double prime, B double prime. The length means the size, so size of the image A double prime, B double prime. The image A double prime, B double prime consists of 1, 2, 3, 4 divisions, and we multiply by the scale along which you have counted the number of divisions, which is the scale along the y-axis. So A double prime, B double prime is equal to 4 times 1, and this will give me 4 centimeter. A double prime, B double prime is equal to 4 centimeter. Okay, so let me write here it is real and inverted. In this case it was erect, and the size of A double prime, B double prime is equal to 4 centimeter. So now when we are in part 3 of this exercise, which is the conclusion. Which one of the two preceding positions of the object AB must we choose in order to obtain a virtual image and erect with respect to the object AB? So as we can notice that in the first experiment we obtained an image A prime, B prime, which is virtual and erect. Therefore the position corresponds to the first experiment. So the answer will be the position of the first experiment. Now number 2, what is the role of L in this situation? Okay, we are in the situation of the first experiment. The image is virtual and larger in size, and we know that whenever the image is virtual and larger in size, this is the role of a magnifier. Okay, since the image A prime, B prime is virtual and larger in size, why larger in size? Because the size of the image in this case is 4 cm and the size of the object is 2 cm. Then I'll place the role of a magnifier. So by this we have finished solving this exercise. That's it for me in this video, guys. Hope it was beneficial for you guys out there watching it, and see you soon in another one.